And welcome to the March meeting of the Ottawa Centre RASC. I'm your host, Paul Klauninger, and extend greetings to all our club members and visitors alike, with a special welcome to RASC members visiting us on Zoom from other centres across this lovely country of ours. All right. Oh, there's my remote. There we go. Yes, there we are. Just a reminder, and I'm sure a lot of folks are happy about this, is that we are continuing to do our hybrid meetings there. We have sloppy weather here in Ottawa for those of you that aren't from this region. So we are recording this webinar for posterity, and it will be available on our website in the near future. For those who are on Zoom, you can use the Q&A function to ask a question to the speaker. And just a reminder that chat box comments can be seen by everyone. Also, the raise your hand function in Zoom is disabled. All right. The Ottawa RASC Centre does acknowledge the trust placed in us by our First Nations with their ancestral lands and skies here. And this is very bulky tonight. I'll do it, Paul. Okay. Thank you. All right. So we've got an interesting program for you this evening. We've got our usual Dave Chisholm with Ottawa Skies for this coming month. And then we've got Bob Olson giving us a presentation on ancient Greek astronomy with a focus on Aristarchus. Jim Thompson will have an announcement regarding International Astronomy Day for us. And then we'll have a break. Sharon Odell is here with a quick update for us on the status of the Dominion Observatory and the work that's going on down there. Then Oscar Echeverri will talk about his very remotely controlled observatory in his backyard. So I found this was an interesting contrast between the very ancient with Greek astronomy and the very modern with backyard astronomies backyard observatories that allow you to do your imaging while you're in a hot tub. But Oscar might tell you more about that. But I thought I'd let that cat out of the bag. We also do have a few observation reports. Last month has been pretty cheesy on clear skies, but we have a few. Then we have our monthly observing challenges, and I'll close it up with announcements. All right. Oh, sorry, yeah, you're going to do this for me. We have 6 new members so far in 2026, so welcome one and all. Are any of our new members here tonight? Oh, we have a couple. Great. That's super. Probably a battery issue. Oh. Okay, thank you. Oh, now I can hear my echo. Super. Next one, please, Chris. So, without further ado, I'll hand you over to Dave Chisholm for our Ottawa Skies report.
So, good evening, folks. Welcome to Cloudy Skies, and let's move on to the next slide. So, the full moon, sorry you missed it, it was on the 3rd. We also had the total lunar eclipse on that day as well. The full moon was known as the chrome moon or the crust moon and the sap moon. Also known as the Lenten moon, as it's part of the timing for Easter. The new moon is on March the 19th. Next slide. So sunrise and set times, as you can see, the daylight is getting quite a bit longer, so we've got to stay up later to do our astronomy. I wish we'd stay on standard time. Maybe that will come someday. Next slide. Mercury is not visible. It's rising and setting with the sun. Next. There we go. Venus is visible in the early evening. Towards the end of the month, it'll be up a little bit later. Mars is not visible. It's rising and setting with the sun. Jupiter is visible in the evening. It's nice and clear these days. It's almost directly overhead. Saturn is not visible. It's hiding with the sun. Uranus is visible in the evening, and Neptune is pretty well rising and setting with the sun. Now, what is this? Spring is just around the corner. There we go. Thank you.
I love that one. That's great, Dave. All right, next one, please. All right, and again, without further ado, I think Bob has probably decided to do his presentation remotely. Is that correct, Chris? Yeah. Yep, there he is. Okay, so we'll turn it over to you. How you doing tonight, Bob?
It's blizzard down here.
Yeah, I think it's starting to get that way here too. So
Yeah.
you made a wise choice. That's a long drive for you.
Well, my wife made the decision. Unlike you guys, I'm more controlled.
Thanks, Bob.
Okay. So many times we read about some ancient discovery, say a 2,000-year-old tomb with a line on it that points to where Vega was 2,000 years ago. And some lunatic scientist will tell us that it was obviously means that 2,000 years ago, space travelers from Vega arrived on Earth and built this tomb. This is a 2,000-year story also, but it seems to be way more probable than space visitors from Vega. Next slide, please. This is about a man called Aristarchus of Samos, who lived in Greece just more than 2,000 years ago. Next slide. The first place I noticed him was on YouTube. In my research, I found this book on Google. It was translated in 1913, and the library stamp suggests that it was in the University Library, Toronto Library, in 1968. How could we have the faintest clue what happened 2,000 years ago in Greece? It turns out that Alexander the Great, a Greek, had conquered Egypt in 305 BC and built a city. And with the usual modesty of conquerors, he called it Alexandria. In Alexandria, there's a great library. One of the characters in this story was its chief librarian. The works of many scholars at this time would end up in the library, and they would have access to the writings of the other scholars. When I taught this concept to my students, I always assumed this library was Arab. Why on earth would I think a city called Alexandria was Arab? It was, of course, Greek. Just a short rant about Google. I do use Google and did most of my research for this presentation using Google. Now, every time I turn on my computer, I'm inundated by articles about ancient Greek characters, and most of them are written by crackpots. Next slide, please. None of Aristarchus's writings have survived these last 2,000 years. So how do we know about him? It turns out that he was well known to another Greek scientist, Archimedes, whose writings did survive. And he mentions Aristarchus in his writings. Everybody has heard of Archimedes and the king's crown. The story is good enough to be repeated here. Archimedes lived in the Greek city-state of Syracuse. The king of Syracuse commissioned a golden crown. Apparently, the crown looked fine, but the king heard a rumor that the goldsmith was known to dilute the expensive gold with cheap lead. Gold does not change its properties if you add lead, except if you add too much, and then the gold gets hard. We've all seen old cowboy movies where somebody bites a coin to test how hard it is. The king asked Archimedes to see if the crown was pure gold, and Archimedes replied, "No problem. We just melt the crown into a cube, measure its size and weight, calculate its density, and see if it is pure gold." The king didn't think this was a reasonable solution and sent Archimedes home to think about a better idea. Apparently, Archimedes' servants had poured him a bath, and when he got into the tub, the water overflowed. Archimedes quickly decided that the volume of the water that had overflowed the tub must be the same as the volume of his submerged body. He realized he could use this idea to measure the volume of the crown. He was so excited that he leapt out of the tub, stark naked, and ran to the palace yelling, "Eureka, Eureka, I have found it, I have found it." Hilarious story, but it was recorded hundreds of years later, and there is no corroborating evidence. And Archimedes never mentioned it in any of his own writings. So we now think the story is just that, a story. Another knock on the story is that the displacement method of measuring volume is probably not precise enough to test the purity of a golden crown. Next slide, please. These are the characters and dates that I will mention tonight. Even though I taught physics for over 30 years, I couldn't imagine how you would figure out the sizes of Earth, Moon, and Sun, and the distances to the Moon and the Sun using the measurement equipment available to the scientists 2,000 years ago. Well, let's see how they did it. Next slide. These are the phases of the Moon as it rotates around the Earth. Aristarchus noticed two things about this pattern. The curved line meant that the Moon was a sphere and not a disk. And the first quarter and third quarter of the Moon must be at 90 degrees to the Sun. Next slide. If the Moon is half covered by sunlight, that would only happen if angle A was 90 degrees. Next slide. Aristarchus then measured angle B and found it to be 97 degrees. Using modern trigs, say trig tables or a calculator, we would quite easily calculate the relative sizes of all the sides to this triangle. These were not available to Aristarchus, but the ancient Greeks were very interested in circles and triangles, and certainly understood similar triangles. If angle B is indeed 97 degrees, then Aristarchus knew that the Moon must be 20 times closer to Earth than the Sun. It turns out 97 degrees is not correct. The correct answer is 89.86 degrees, or nearly 90 degrees. This means that the Sun is much further away than Aristarchus figured. Why would he be so wrong? It is difficult to tell exactly when the Moon is half covered. And also, the Moon and the Sun are both 1/2 degree in size, so it is hard to measure the exact center of them. I also imagine that looking at the Sun to make a measurement would it be at best distracting. His measurement was less than 2 degrees wrong, but those 2 degrees make a large error in his distance. The Sun is not 20 times further away than the Moon, but is instead 390 times further away. But wait, I hear you say. The Moon is out at night and the Sun during the day. How can we see them both at the same time? Yes, but you forget the Moon is often visible during the day. Apparently one afternoon, Mount Palomar was phoned by a citizen asking, "What is that object in the sky that looks exactly like the Moon?" When told it was the Moon, the citizen slammed the phone down, exclaiming, "You take me for a fool?" Next slide. Occasionally, the Moon gets between the Earth and the Sun for a solar eclipse. Next slide, please. In the sky, the Moon and Sun are exactly the same size, 1/2 degree. Thus, the Moon just barely blocks the light from the Sun. Both the Moon and the Sun look the same size in the sky, that is 1/2 degree. You might feel that this is too big a coincidence to not have some root cause. Well, I hate to disappoint all you conspiracy theorists, but it is a coincidence. There are many other planets and many other moons, and no others are the same angular size as the Sun when viewed from the planet. Next slide, please. Since the Moon and Sun look exactly the same size in the sky, and the Sun is 20 times further away, that means it must also be 20 times bigger than the Moon. Remember, Aristarchus didn't have the 20 times quite right. It was actually 390 times bigger. Next slide, please. Every once in a while, the Earth blocks the light that would normally illuminate the Moon. We call this a lunar eclipse. Next slide. This is what it looks like when the shadow of the Earth starts to cover the Moon. Notice the shadow has a curve. This is how the ancient Greeks, 2,000 years ago, knew the Earth was a sphere. Only a sphere makes a curved shadow, no matter what the angle is of the sphere. They were also very suspicious about the shape of the Earth as ships sailed over the horizon. Aristarchus used this curvature to estimate the relative sizes of the Earth and the Moon. He made a guess that the Earth's shadow was 2 times bigger than the Moon. Next slide. With modern time-lapse photography, it is much easier to make these measurements. Next slide. It turns out the shadow is about 2.7 moon diameters. Aristarchus guessed about 2 moon diameters. Since he didn't have astrophotography, we are suspicious that he timed how long it took the moon to traverse the shadow, and the moon doesn't always go through the center of the shadow. Next slide. As you can see from this exaggerated illustration, the shadow of the behind the Earth narrows. So where the moon goes through it, the shadow is narrower than the diameter of the Earth. This makes the Earth about 4 times bigger than the moon. Next slide, please. Even though his answer was quite wrong, mostly from getting the angle of the sun wrong, he did realize that the sun was significantly bigger than the Earth. Next slide, please. Looking at this diagram of the moon orbiting the Earth, I should point out to you that the orbit of the moon is not actually lumpy. During the lunar eclipse, the moon travels through the shadow of the Earth. Aristarchus knew that this event took about 3.5 hours. He was also aware that the moon took 28 days to orbit the Earth. This allowed him to compare the radius of Earth's orbit to the radius of Earth itself. Next slide, please. I will not torture you by going through the mathematical reasoning, as you can see it for yourself, and I imagine that it will be in Astronotes. I will just point out that the 2RE is the diameter of the Earth, and that's what takes 3.5 hours. His answer of 61 Earth radii is astonishingly accurate. The orbit of the moon is not circular, think supermoons, and varies between 56 and 64 Earth radii. Next slide, please. Another way to calculate the moon's orbital distance in moon diameters is to watch a moonrise. It takes about 2 minutes for the moon to rise clear of the horizon and about 25 hours till the next moonrise. From that, you can calculate the moon's orbit diameter in moon diameters. In this photo, is this photo a moonrise or a moonset? The full moon sets with the sunrise, so you can't really see it. It's definitely a moonrise. Next slide, please. Aristarchus reasoned that small objects should rotate around big objects. Therefore, the Earth must rotate around the sun. He came to this conclusion 2,000 years ago. Next slide, please. Aristarchus had the relative idea of the sizes of the moon, Earth, and sun, and relative ideas of the distance to the moon and the sun. He needed the ability to put real numbers to these relative sizes and distances. That brings us to Eratosthenes. Eratosthenes lived about the same time as Archimedes. He was the chief librarian of the Library of Alexandria. Archimedes was in constant contact with him as he wanted the information the library contained. It also seems that Archimedes was trying to impress his fellow scientists. Next slide, please. Alexandria in Egypt was thanks to Alexander the Great, part of Greece. Next slide, please. The burning of the library is one of the tragic stories of history. It is not clear who destroyed the library, or if it was indeed destroyed. In history, if you want to make somebody look bad, accuse them of burning down the Library of Alexandria. It seems possible that the library never burned at all, but just faded away. Next slide. There is another town in Egypt called Cyrene. It is about 800 kilometers south of Alexandria. This puts it right on the Tropic of Cancer. On the June solstice, the sun would be directly overhead. That means if you look down the well at noon, you would see the reflection of the sun in the water. Next slide, please. Eratosthenes heard of this, and on the June solstice in Alexandria, he noticed that a tall column cast a shadow, and the sun was not directly overhead. He correctly deduced from this the difference was caused by the curvature of the Earth. He could measure the angle of the shadow and the distance between the column and the well. This would allow him to measure the circumference of the world and thus its diameter. Next slide, please. He was really good at mathematics, so the angle was easy. But how did he know how far it was to Cyrene? He never did tell us, so we can only guess. There were cartographers at the time called pacers, and they may have counted the paces to Cyrene. He may have known how long it took a camel train to get there. Anyway, he knew the angle was 7 degrees and that it was 5,000 stadia to Cyrene. 7 degrees is about 1/51st of a circle. That makes the diameter of the Earth 255 stadia, and this gives a very close answer of 40,000 kilometers around the world. The problem with this answer is we don't know how big a stadia is in kilometers. We think we know it might be the size of a stadium. We know the distance of Cyrene is 5,000 stadia from his notes, and that the modern map show that we know that the distance is equal to 790 kilometers. So we get the right answer for the circumference of the world. But this all depends on the conversion which we choose, and it gives us the right answer. This is a circular proof, so a little incestuous. Next slide, please. If you know a bunch of the relative distances and then solve for one of them, you know the rest also. Did Aristarchus know the work of Eratosthenes? Well, they both worked in Alexandria, both lived into their 80s, and Aristarchus was 34 years old when Eratosthenes was born. So it is hard to believe they did not know each other, but there is no record of their calibration, no written record of their calibration. Next slide, please. Aristarchus's writings survived. Archimedes' writings survived, and we know they were read by Copernicus and Kepler. Next slide, please. If Aristarchus had a sun-centered solar system 2,000 years ago, why was it abandoned? The first objectors that I could find were Archimedes and Ptolemy, and they weren't exactly dummies. Aristarchus figured that the sun was way further from the Earth than had been previously guessed, but even he didn't realize how far away the stars actually were. The sun is about 8.5 light minutes from Earth, but the nearest star is 4 light years away. Stars are more than 250,000 times as far away as the sun. Archimedes and Ptolemy thought the stars were just a little bit further away than the furthest away planet. As you can see from this diagram, when the Earth is on one side of the sun, it is much closer to the stars than on the other side of the solar system. Archimedes and Ptolemy figured that the stars would be further apart when the Earth was closer. Next slide, please. This problem goes away if the Earth is the center of the solar system. Over the next 2,000 years, this solution was accepted and even became religious dogma. Next slide, please. Today, we feel confident the Earth does go around the sun, as Aristarchus suggested. And if you look at this diagram, you can see that the close stars should indeed move relative to the distant stars. Next slide, please. This Danish astronomer was the first person to notice, measure, and publish the parallax of stars. He did this in 1834, sorry. There were a couple of other people who almost certainly measured the parallax a year or two earlier, but they didn't publish the results until after Frederick. Next slide, please. How hard is it to measure this parallax? I will use my own telescope as an example. It's a 12.5-inch Newtonian, and I use a camera with 8.3 million pixels. Each of my pixels is 5/1000th of a millimeter across and measures only 1 arcsecond of the sky. The parallax of the stars is only 3/4 of an arcsecond. My scope would have trouble seeing it. Next slide, please. As far as we know, Aristarchus was the first person to suggest a sun-centered solar system. This diagram of a solar system may not be to scale. Next slide, please. He has been honored by having a lunar crater named after him. I show this with a sketch to honor our lunar sketchers, Brian and Gordon. By the way, this is not my sketch. Next slide, please. While researching this presentation, I came across this cartoon, which I thought was hilarious, as I'm sure most people would not get it. Next slide. Thank you.
Well, thank you very much, Bob. Do we have any questions on Zoom or in the audience? No, I don't see any hands up. We good? All right. Well, thanks again, Bob. That was entertaining. All right. I don't think this is still working out. Next one, please, Chris. All right. So is Jim? Oh, you are here. I didn't see you. Jim Thompson is going to give us a bit of an update on International Astronomy Day. Thanks, Bob.
So the clicker's non-functional.
Just ask Chris to advance it for you.
Well, I'm sure you've all noticed by the gale force winds and blowing snow that spring has arrived in Ottawa. And one of the exciting parts about spring is that International Astronomy Day is very near. So what is International Astronomy Day? Well, it was a public event started in 1973 by the Astronomical League in the U.S. The idea of the event is to promote an interest in astronomy and science in general amongst the general public, giving people an opportunity to look through a telescope who might not have had an opportunity to do so before. It's an opportunity to share views of fairly achievable objects from a sidewalk, sun, Jupiter, moon, Venus, some the brighter objects, but also now with modern technology, we can also share views of deep sky objects like galaxies and nebulae. So the next date for this event is coming up just over a month, so Saturday, April 25th. Next slide, please, Chris. To give you an idea of what the event looks like, these are some pictures from the past events. The event that I organize, it's going to be a jointly coordinated activity between RASC Ottawa branch and another Ottawa group in another astronomy group in Ottawa called the OAOG. I'm the coordinator for the event. It takes place in the parking lot next to Chapters Silver City, so that's in the east end of the city. There's a few photos here. You can see the amazement, on the young kids' faces. This is my daughter. She's a paid actress in this shot. And my son also, he's also a paid actor. But kids of all ages have a great time. I spend probably more time talking to adults about astronomy during this event. They're as excited or more so than the kids are. So it's a great opportunity to get out, meet amateur astronomers in your community, share your passion for astronomy with the public, and maybe someday one of these young people will grow up in the profession of science or engineering. Next slide, please. So the event officially runs from 10 in the morning till 10 p.m. We focus on viewing the sun during the day, and then once the moon is up, coincidentally, the date is selected when there is a first quarter moon, which puts the moon in a really advantageous position in the sky to show people. That's how the date is selected. So sun during the day, once the moon's up, we'll be sharing views of the moon, and then Jupiter is still going to be high in the sky. We'll be able to see Venus. And then a few people will be bringing their robotic telescopes or EAA setups to share views of galaxies. Runs from 10 to 10, although people show up earlier to set up. You don't have to be there the whole time. If you can only spare a couple of hours, then that's perfectly fine. It's, as I said, the parking lot next to Silver City Chapters, 2401 City Park Drive. It's a terrible place for observing because there's lights everywhere, but there's also lots of people, and that's the objective, is to expose astronomy to as many people as possible. If you would like to participate, feel free to contact me. I'm looking for volunteers to come with their scopes, but I'm also looking for volunteers to just come and answer people's questions, watch somebody's gear when they go to the bathroom, that sort of thing. And if you don't want to do either of those roles, then just come as a guest. Come and talk with some of your fellow astronomers in the Ottawa area. So my contact details are there, the email address, and there is a website if you want to get some additional information. Right, thank you.
All right. This slide just came to me recently, and I thought I'd share it with you guys. This is a letter sent to me as the meeting chair from a postgrad student in the United Kingdom who's doing his dissertation, and I assume it's part of his overall research project on the meaning and motivational aspects of astrophotography. It's interesting. He says, if you're engaged in the hobby of astrophotography, your participation in this study would be greatly appreciated. Please note that participation is voluntary and confidential. I get the feeling that he's just looking for I guess, a gut feedback from people that are like us, that are into observing the sky or imaging the sky, or just fascinated with astronomy and keeping our eyes to the sky. So if you are interested in participating, it's a survey that he says will take about 10 minutes to complete. I guess he has a fixed list of questions, and I'll ask our astronauts folks, Doug, to put this information in the astronauts so that you can get the link if you wish to follow up on that. So totally voluntary and at your discretion. His name is Stephen Burr.
He's actually a member of the Belleville Center.
I saw that.
Lives down in Prince Edward County. And if you've ever had a chance to go to the Fallen Stars Star Party, which takes place in September every year, the Kingston-Belleville cooperative effort, he's the one who, his in-laws own the property where we do the Star Party.
Oh, wonderful.
That's why he's circulating around sort of local astronomy groups.
Okay, so he's a local astronomer that happens to be studying in the UK.
It's an online degree.
Oh, I see. Okay, all right. Well, that takes away one of my concerns there. I was going to end my little description of this saying that this is an untested link and stuff like that. And I know these days we have to be cautious of scams and things like that. But I would take it from what you've said, Rick, that this is bona fide. It's genuine. And
A number of us from Kingston have already done it.
have you? You have, eh?
Yeah, with no consequences.
Oh, wonderful. Okay, so there you go. So feel free to follow up on this if you wish to share your thoughts on the stuff that you do in astronomy and astrophotography. And as I said, we will publish the link in Astronauts that you can follow up on. Great. Thanks for the info on that, Rick. Next one, please. Oh, bio break time. Okay. Well, we're running good time tonight, and. We can get the lights down. And we can go with the next slide, Chris. All right, just before we begin with our second part of the program, just want to highlight a few of the benefits for people that are new or just tuning in that aren't already members. The benefits of membership with the RASC are numerous. Next slide, Chris. Biggest thing I found, and I say this repeatedly, is a chance to chat with folks that have similar interests and similar knowledge, and to share things and share opportunities to observe, and just thoughts in general about astronomy and astrophotography and all things celestial. So definitely one of the big benefits. Next, please. We also have a couple of libraries. An unusual one is our Ted Bean Loan Library, where we actually lend out telescopes. We do have a fair collection of telescopes that we lend out to members. If you've not got a telescope and you're thinking of buying one, this is a great opportunity to try before you buy, as they say. So that is available to our members. We have a book library with a new librarian. Rachel Chen has agreed to take over the spot there, so we're very grateful for her participation. She's relieving Estelle, who did a very good job over many years minding the books and other materials that we have there. Excuse me. We also have our observatory out in near Almont, the Fred Lossing Observatory, where we have 3 telescopes in their own buildings there, and it's a reasonably dark site to come out. If you've got your own equipment, you can come out and set up there. On we have observing nights, but to members it's open all year round, road conditions permitting, of course. When we get 20 centimeters of snow, it's a little bit challenging. But we have a nice open area there where you can set up your equipment as well if you want to use your equipment under dark skies, which is especially nice for folks that live in the city. Next one, please. You also, as a member, get access to our monthly Astronauts and the journal put out by the RASC, which is a fairly technical publication on a variety of different articles related to astronomy. Plus, you get the Observer's Handbook, which is a real gem for the data that it contains. We even have articles. It's full of articles written by experts, including our own Jim Thompson, who did a nice job on the filters that we use in astronomical observing and imaging. But it's just chock full of data that is nice to have on hand, especially if you're in an area where there may be no internet connection. So yeah, you can, if you're looking for this bit of data or that bit of data or some timing, it's a handy reference to have, and it's been around for many years. Next one, please. We also have our own Discord server. This is for members only, again, where you get to share your ideas and strike up conversations with other members of the club. You also get a discount on Astrospheric Pro, which is a really nice supplement to your membership. Astrospheric is a really neat application that contains a whole variety of up-to-the-minute data on weather conditions, sky conditions, and so forth. And the Pro version gives you extras as well, which as a non-member you would wind up paying $66 a year for. That comes to you free with your membership with the club. All right, next one, please. And so the membership fees are as stated here for regular membership. In other words, one person, $118. We get a family membership at $112.50 plus the amounts that are stated there for an additional adult and youth. And we also have a youth membership cost at $77.40 for folks under 21 and under 25 if you're a student. Next one, please. I think that's it. Oh, there we go. So that's it for my short announcements here. We have an update, a brief update from Sharon Odell on the latest happenings at the Dominion Observatory and how they're dealing with the prospect of having a hospital built all around them. So I think Sharon is. Oh, there you are. How are you, Sharon? You're good. All right. So
I'm good.
I'll hand it over to Sharon. Away you go.
Hi, good evening, everyone. It's just a brief update about a couple of projects that our Dominion Observatory Preservation Committee are working on as part of an ad hoc committee of the Royal Astronomical Society of Canada's Ottawa Centre. And the first one here is about the latest public consultation for the Ottawa Hospital, the construction beside the Dominion Observatory campus, which is located on the Central Experimental Farm on Carling Hill, which is up against Carling Avenue. The first deadline was for comment on the 17th of March, which is coming up this week, but we just received news as I was creating these slides that they've given an extension until the 26th of March. You can find this on the City of Ottawa website at ottawa.ca. It's called the Planning Circulation Extension, 900 Carling Avenue Site Plan Control. The document or the ID number for this is D0712260008. And the links are here, but I can also send them to anybody who's interested. I can give that email in the next slide. Next slide, please. This is the letter that details the extension for the site plan control revision. They've added some extra things this past week, and so the comments are now due on the March of 26. Hopefully, if anybody is interested in this, you can take a look and please give your comments. We are looking at the lighting around the hospital, so to have capped off lights so there's less light pollution. And we're looking at keeping the azimuth, which is very close to Maple Lane, which goes beside the observatory from Carling Avenue, to have bollards around it so that the emergency vehicles such as ambulance and fire truck don't harm it, and to have some kind of conservation about road salt. The next slide, please. We also have the second project that we're working on. We're registered with the Doors Open Ottawa for 2026. This is the 24th anniversary of Doors Open, and this will be happening on Saturday, the 6th of June, 10 a.m. to 4 p.m. We're calling out for volunteers as we did last year and the year previous. Our first year at the observatory doing Doors Open, I believe, was in 2023. And then we did it again last year in 2024, and then I think 2025 as well. So this year might be more. It depends on the weather, of course, but the weather was excellent last year in 2025 and 2024. 2023 was just the start, but we hope to have that nice weather and to do solar viewings and tour guiding of the history of the Canadian Astronomy program, and talk about light pollution education, and talk about RASC Ottawa Centre to give promotion to that. If you're interested or if you have any further questions about this, please contact us at the Dominion Observatory Committee at gmail.com. That email we look at quite often, and we can answer any questions, or if you're interested, please send us some mail. Thank you.
Thank you, Sharon. All right, and for our second presentation, is Oscar, did Oscar step out? No, he's right here. Oh, there. hiding behind the curtain. Okay, give us a second there, because Oscar's got to plug in his computer, and he will then show us all about his backyard observatory. There you go, sir.
All right, thank you. Just give me a moment here to get set up. Chris, it's not letting me share again. It's saying I have to be a host. That's not right. There we go. Okay. Is that right? Yeah. Okay. Cool. Sorry for taking a bit to set up there. So my name is Oscar Echeverri. I'm going to be doing a quick presentation on sort of the process of automating my observatory to the degree that I have. So we'll talk a little bit about the location, where my observatory is, my motivations for taking it from sort of a basic backyard observatory to mostly automated and remotely operated observatory. Some stuff about the sort of the original setup I had, just to kind of give some context on the journey that had to be gone through to automate, what the current setup looks like. Kind of a view into the architecture of how all the components interact. Kind of what my workflow looks like when I'm conducting an imaging session in the observatory, and then maybe I'll talk about a little bit about sort of some future improvements I want to undertake in the observatory. All right. So first of all, for location, here's a sort of a big map of our area. That's where we are right now at the Aviation Museum. The Fred Lossing Observatory is way to the west there, and then I'm kind of right there. And then if you overlay a light pollution map, I'm kind of like right there, and pretty nice skies. Could be nicer, but my wife would only let me live so far away from the city. And and a little bit about one problem with living in the country, and in the woods, is that there's trees. So the next couple sort of images show what my local horizon looks like. So this would be like the view facing north from my observatory, the green areas being trees, the brown being ground. Here's to the east. To the south is pretty nice. It does get pretty low. I wouldn't want to be imaging much lower than where the trees are anyway. The west has a little gap, but again, you kind of start to run into trees in the northwest. So that's, and then if you look straight up to the zenith, I kind of have this small window to image through. Yeah, so what were my motivations for automating this, my observatory? Was to cut down on the friction points in using the observatory and imaging. Some of that was like target selection, trying to figure out which targets weren't behind trees at a certain time. I wanted to be able to make multi-night projects easier to do. So being able to replicate, if I'm imaging, say, the Orion Nebula for 5 nights, if we ever get that many clear nights in a century, I want to be able to have my gear set up in exactly the same way, have the exact same framing for the image, have the middle of the frame be the same night to night to night. I wanted to be able to make multi-target nights possible. So, let's say my first target of the night sinks behind the trees 2 hours later. I don't want my observatory to just sit there taking pictures of trees. I want it to kind of know when the target has gone behind the trees and pick a different target that I've put in the queue. Again, goes well into optimizing target selection for my limited horizon. And I wanted to be able to control and monitor the observatory from indoors, because we have 2 seasons here, which are mosquitoes and winter, and I like neither. And when I was young, in my 20s and you know, a little bit into my 30s, I could stay up all night and still be functional the next morning. And now I'm in my 40s and I have a 6-year-old, and when I don't get any sleep, I'm a zombie, and I, you know, run a hazard of getting fired from work. So I want to be able to, you know, push some buttons in my observatory and have a sound night of sleep, knowing that, you know, it's going to be doing some work, and that I'll be notified, I'll be woken up if something goes wrong. So my original setup was a skyshed pod on a deck that Paul helped me build. I have an 11-inch Celestron Edge HD. I was on a Celestron CGEM DX. I was using a Canon 60DA. I had a piggyback refractor with an Orion SSAG as my guiding setup. I would focus manually with the focuser knob and a bat knob mask. I had a computer and keyboard and mouse and monitor in the observatory structure itself that would run the capture software. And then I was using Backyard EOS to control the camera and capture images. And then I would drive the telescope with the hand controller on the mount itself. Or sometimes, if it worked, I could use the virtual hand controller on the PC, which seldomly worked. Thank you, Celestron. So once it was constructed, that's what the observatory looked like, or looks like still. All right, so in order to be able to automate some of that gear, I needed to, or automate my setup, I needed to make sure that all of the crucial pieces of equipment were able to be controlled by software. I needed a new software stack in order to be able to control all the various different components and have an automated sequence for imaging. So I ended up settling on a piece of software called Nina, which is an open source software to control the hardware and do the sequencing. Another open source piece of software called ASTAP for Nina to use as a plate solver. And then PhD2 was still a great piece of software that I was using previously to control the guiding on the rig. So yeah, so what did I need to throw away and replace with better things? So first of all, the first victim of my original setup was the manual focusing. Why? Well, manual focusing is time-consuming and tedious, especially when you're cold and tired and you're swatting mosquitoes off your back. It's really easy to screw up once you've gotten kind of tired and impatient. You know, you might kind of put your bat knob mask on, focus it, and then say, good enough, and then you find out the next morning your focus was way off. The focal point varies over the course of the night, so as your telescope cools, the metals contract a little bit, and the focal point changes, so you need to refocus. And when you're imaging with the Schmidt-Cassegrain, the focal point is also a function of where you're pointing. If I focus while I'm pointing at the zenith, and as my telescope follows a target towards the horizon, the focal point is going to change because of the way the mirror is mounted to the focusing mechanism. It can, as you start to point downwards, the mirror can slop a little bit, and that'll change the focal point. So I really wanted to be able to periodically refocus automatically without me having to be awake or present in order to combat those issues. So I ended up settling on a piece of hardware called a Celestron focus motor, which was sold by the telescope manufacturer. That basically just, you remove the focuser knob and this little motor here. Oh, does the laser not work? No. There it is. Yeah, so you mount this motor onto where the focuser was. It just basically clamps onto the focuser shaft, and then it bolts into this little plate here. So it's hands off. I can automate it. Nina has a fantastic autofocus routine to be able to pin the focus really tight. and it's fast and repeatable, and I don't need to be there to make it happen. All right, so the next thing that needed to go was my camera. I was using a Canon 60DA, which was a fantastic camera. I still have it. I still love it. But it's not a particularly sensitive camera. It is manufactured for. It's just a modified 60D, so it's manufactured for daytime photography mostly. Just the filter on it slightly different to allow more red light in. It's powered by battery, although I know there's like a dummy battery you can get, but that adds complexity that I didn't want. It occupies a ton of back focus. So the back focus is kind of the distance from this surface to where the sensor is. So it's 44 millimeters there. And with the Schmidt-Cassegrain, especially like the Edge HD, you need to. There's a very precise distance that you need to hit from the back of the telescope to your sensor. So if your camera is eating a bunch of the back focus, that limits your options for what else can be in that imaging train. So things like an OAG or a rotator or what have you, those also eat up back focus. And if your camera is eating a bunch, then fewer options there. So I ended up replacing that with a ZWO ASI 2400 MC. So it's ultra sensitive, it's a cooled camera. And that's an important factor because it means, this kind of plays into being able to do multi-night projects where I can reproduce the temperature of the sensor because the noise the sensor has to it is a function of its temperature. So if I can get the sensor of the camera to be the same night to night to night, then it's easier to then remove the noise in post-processing. These sensors themselves are much less noisy anyway, so it helps there, and it's powered by 12-volt DC, so I don't have a special battery that I have to charge in order to operate the camera. I don't have an AC-powered dummy battery that I have to plug into the camera. It's just powered with the rest of my 12-volt DC from a 12-volt DC power supply in the observatory. So yeah, another thing that I replaced was my guide scope. Why? Well, with that 11-inch Edge HD, it's a really long focal length. And when you're guiding with a separate telescope, you can get something called differential flexure, where the body of both the main scope and or the guide scope can flex a little bit, or the mounting points flex a little bit, and they flex differently relative to one another. Which can throw off your tracking at that level of magnification, because from the perspective of the guide camera, it might be seeing stars moving ever so slightly that aren't actually moving. It's just that the telescope is sagging a little bit, so it'll try to correct for that. But then the main telescope maybe isn't experiencing that drift. It also has a separate focusing mechanism, which is another thing that needs to be focused through the course of the night, because it's also changing and at a different rate from the main telescope. And then another factor is that it's a heavy piece of equipment sitting on top of the telescope, which puts it quite far from the rotational axis of the mount. So it makes it more work for the mount to have to move around, which then reduces kind of the tracking accuracy of the mount itself. So I just ended up replacing that with an on-axis guider. So that kind of sits in front of the camera. And so the camera ends up being bolted onto here. The telescope is on the other side. And then this little guide camera goes into there. There's a little pick-off prism that kind of comes down and through here, and it grabs some of the light from the primary light cone coming into the telescope. And directs it to the guide camera, so you end up guiding on exactly the same field of view that you're imaging, so you don't have any issues with differential flexure, because both cameras are looking at the same light cone essentially. And then the other advantage is that it's the sensor for this camera, when set up correctly, is sitting the exact same relative distance to the back of the telescope as the main camera, so their focal distance is exactly the same. So you just need to refocus the telescope, and then you're focused on both cameras, so I don't have to fiddle with two different focusers. The one drawback is that because you're using a small little pick-off prism, you're only getting a small bit of light out of that light cone, so you don't shadow your main camera. So you do need quite a sensitive camera in order to be able to guide with this. So this little camera ends up being quite expensive. Although I think it's come down in price now. But all right, and then the final piece of gear that I added was a rotator. And a field rotator, this ends up sitting, the telescope sits on one end, and then the guider and the main camera sit on the other side of it. And then it's able to basically rotate the image train behind the telescope so that I can tweak the framing on a given target. Let's say a galaxy, is at is exactly parallel to the long axis of my sensor. Maybe that's not the way I want to frame it. Maybe I want that to span diagonally across the field. I can have the rotator rotate the image ever so to get exactly the framing that I want. And then it also enables that idea of multi-target nights where, I might be imaging one target and I want the camera rotated a certain way, but when I switch to a second target, I want it rotated a completely different way. And with Nina and plate solving, you can kind of put these concepts together, and Nina can drive the rotator to kind of frame the image the way that you wanted it to. All right, so the software stack, as I mentioned earlier, I was using PhD for guiding, ASTAP for plate solving, and Nina for telescope and gear control and camera and image capture. So all of that is like on a mini PC that's mounted to the telescope's pier, and it's all just running on Windows. So it's pretty standard stuff. There we go. And then this is kind of the block diagram or architecture of the system. So you've got all the inside this box is everything that sits in the observatory, which is like the telescope that has the camera focuser, rotator, guide camera mounted to it, and those are all connected by USB to the mini PC that's running the software, and then I have a power distribution box that's hooked up to the PC by USB, and then it distributes power to the various components and the PC as well. And then I drive this from my house or from my hot tub, as Paul was saying, remotely over my LAN or over the internet if I VPN in, so that I can use like remote desktop into the mini PC to control all of the different things going on. All right, so what does my workflow look like on a given night? I have a couple manual steps right now, which is I have to open the dome, and then I have to push the roof off. So it used to be more of a standard dome where you would rotate the roof, but I found that with the size of my telescope, it limited my ability to image to the zenith because the dome would kind of come up over the top of the telescope. So I modified the observatory so I could push the roof completely off. So that's what I do manually right now is I open the roof, push it off, then I push a couple buttons and get things going. And what does that look like? So it, I launch Nina. That's what kind of it looks like when you launch it. And then you can connect your camera, focuser, rotator, mount, guider, or you can just be lazy and push the one button that connects them all simultaneously. All right, so once that's done, then it's time to select the target that you're going to image. So they have a little sky atlas where you can search for targets with various criteria, whether it's a kind of object that you want, or maybe you just want to say any object that's above the horizon, or I think you can even filter by catalogs. And it'll also take your local horizon if you've inputted local horizon into consideration when you say above the horizon. So here I think I just said I want to see all the galaxies that are available between 5 arc minutes and 30 arc minutes, so it produced this list on the side. And if you kind of zoom in, you can see that this chart is my local horizon, and then these are the paths that those targets would take through the sky. So, you know, I kind of didn't want to image any of these because they're behind the trees, behind the trees, behind the tree. Doesn't even come up over the real horizon. This one has a bit, but only kind of, you know, between 2:30 in the morning and like 4 o'clock. So I didn't want to image that. So, you know, I thought, well, I'll just image M51 because I know it was okay. So you can search also by name. And then once you've selected the target that you want to image, you can add it to your target sequence. And then you can go to the next phase, which is to actually frame the target the way that you want to. So initially, it'll kind of show you this view with the camera at 0 degree rotation. But you know, maybe you want to image this one rotated 90 degrees, so you can kind of adjust the rotation, and then it adjusts the framing. But if you want to see like more of the surroundings, you can increase the field of view, and then that's kind of so you can see the whole frame. And you can drag the frame around so that, you know, maybe you don't want the galaxy in the middle. Maybe you want to move it around a little bit. So once you're happy with the framing, you can add it to your target sequence, and then you can define different imaging sequences. I happen to have a couple here, but for this, I was just going to use one-shot color target because I'm just using my OSC camera. Yeah, so that's how you kind of frame your target. And then the next thing is to do your sequencing. So this is where Nina really, really shines. It has a lot of options for like a sequence start. Maybe you want to do a bunch of stuff with your gear before you actually image. And then once you're actually imaging, like maybe you want to wait a certain amount of time, or you want to take a certain number of images, or you want to whatever. The options are kind of infinite. And then you can get to an end sequence where you can say, okay, well, once all the imaging is done, maybe slew the telescope towards the ground so that the birds don't poop into it, and park the mount so it doesn't drive itself into its own legs. But yeah, so look, why don't we dive into like what one of my typical sequences might look like. So I have like a start sequence that I usually do, which is the telescope will wait till nautical dusk, and it does that or Nina will wait till nautical dusk, I should say. So it does that, it calculates that based on the time of year and your GPS coordinates. Once it reaches nautical dusk, it'll cool the camera, then it'll slew to the intersection of the meridian and the celestial equator. And and then that's where it does it focuses at that point, and then it calibrates the guider. I slew to that portion of the sky because that's where tracking error will be most exaggerated, so it's good to calibrate at that spot. Once I've calibrated the guider, I have an instruction to plate solve, and then it syncs where the mount is actually pointed to the mount, so that the mount's pointing model matches to where it's actually pointing. And then I park the mount. So once the start sequence is complete, it goes into like the target sequence. And for that one, it waits until 10 minutes before astronomical night. And it also waits for the target to be above the horizon, so both real and local horizon. So it'll wait for my selected target to be above trees, basically. At that point, it'll run a focus routine. It'll plate solve to make sure that it's still pointed. It'll plate solve to make sure it's pointed at the right spot. It'll recenter if needed. And then it goes into the main imaging loop. And the main imaging loop is just basically a set of instructions that it just repeats over and over and over again until it meets certain conditions. So generally, my exit conditions are usually like, once we reach astronomical dusk in the morning, astronomical dawn, I should say, in the morning. But yeah, basically it'll expose, it'll plate solve, it'll analyze the image to see whether the sizes of the stars in the images have gotten large, or whether it can't see anything at all. And then it checks against some conditions, whether, based on the plate solve, have we drifted a lot? Do we need to recenter to make sure we're imaging in our frame? Based on the sizes of the stars, do we need to refocus? And then there's also some fixed refocus points as part of those conditions. So for me, I have it refocus every 45 minutes, no matter what, or any drop in temperature, or any change in temperature of more than 3 degrees Celsius, or if the stars have gotten about 5 or 6% larger than if the trend over the last number of exposures is an increase of 5% or more in the average size of stars. So it'll repeat that until the end condition is reached. At that point, it goes into the end sequence for my imaging sequence, which is it warms the camera up, it stops the guider, it slews to a park position, and then it parks the mount so that it stops tracking. And any given sequence can have one or more target sequences. So I might say, image M51 until midnight, and then slew over an image M101 for a period of time. Or I might do something like, image M51 until it's behind the trees, and then go image this other thing, and then come back to M51 once it's back out of the trees. So that's cool and all. It'll run, it'll do these things, but then how do I get a good night's sleep? How do I know if things are going right, if it's not working? So I have a number of notification triggers. So I get a buzz on my phone when the sequence starts, when a sequence ends, if any of the devices have any USB connection issues, if the guider loses the guide star, if there's any failure in focusing or failure in plate solving, which can both be indications of clouds, or if there's any other errors. And then depending on the severity of the errors, it'll buzz louder or quieter. And then I use a service called Pushover and a plugin in Nina to send those notifications to my phone. All right, so that's more or less it for kind of the main workflow. It's pretty close to being fully automated. There's a couple things I still want to work on and improve, which is I want to figure out how to motorize my roof so I can just push a button from inside and not have to go outside and fudge with the roof. I want better or actual local weather monitoring and notifications. Right now I'm using, like I said, the guide star, like the guider losing its guide star, or being not able to plate solve as a proxy for clouds, but the field of view of my telescope is quite small. So it could be looking at a patch of sky that's perfectly clear and there's a thunderstorm rolling in from the other side of the scope, and I wouldn't know until, everything's fried. And then, I want to be able to shut down automatically and close up the roof and stuff if there's any emergency conditions. Right now I'm the emergency condition solver. If anything goes wrong, I run outside and shut everything down. But yeah, that's more or less it. Any questions or anything?
Sorry, please use the microphone.
Where's the question?
Oscar, how do you handle cable management? Something I've always struggled with.
Yeah, so I've solved that by having everything mounted to the telescope. So the computer's mounted to the telescope, the power distribution's mounted to the telescope, and then I just Velcro things to the side of the scope so that the cables don't get all tangled. I still have that cable management challenge when I'm imaging in the field with my field setup. I try to limit the number of cables that hang off. So if I'm imaging from a laptop, I try to mount a USB hub to the telescope, and then just have one cable coming down to the PC. That's more or less the best you can do, and just being organized and trying to loop cables around things so that they're not just hanging.
We have 3 questions in Zoom. The first one for you, Oscar, from Neil. What software is used to create your horizon views?
So I used... so Nina takes a horizon file, which is just a comma-separated values text file with the azimuth, that you're facing and the altitude of your horizon at that azimuth. I used an app on my phone called, let me see if I can find it. I've only used it that one time, so that's while I scroll, I'll tell you what it does. But it basically it'll generate, it'll take pictures and it'll annotate the azimuth that I'm facing and the altitude that I'm pointing my phone at. And so all I did was basically take a picture, turn a couple degrees, take a picture, and I just did that in a full circle from the inside of my observatory to kind of map it manually. I used one called Observer Pro. That was one that I used. Observer Pro. And I think I originally used a different one, which maybe I don't have on my phone anymore. But both of them were a similar premise. I think Observer Pro is a little bit smarter in that it just uses the original one I used is called Theodolite, Theodolite. But Observer Pro is better because rather than taking pictures, you can it'll show you the view through your phone's camera, and then you just trace the horizon with the reticle on the phone, and it'll record the azimuth that you're facing and the altitude that you're pointing, and then it'll spit out a file in the format that Nina takes. And then other software will take that format as well, so I think you can import the same horizon file into Sky Safari and with a little bit of modification into Stellarium, yes.
Thanks. The second question from Bernie. Are you able to create a workflow on your PC in the house and send it to the mini PC?
Yeah. If I can run Nina on a Windows PC inside my house if I had one, and I could export it as an XML document. They have an XML format that they use, and you could drop it into the other computer and open it from there. Yeah.
And the third question from Mick. How long in minutes for the startup cycle compared to manually starting up?
I think the biggest time saver is in focusing. I think focusing manually, if I wanted to do a really good job of it, would take me 5-10-ish minutes. I don't know. The software will refocus in about a minute and a half. And then slewing manually, I guess to the spot would be kind of, I don't know. Time savings is mostly in me not having to walk out to the observatory. I guess there's that too. I don't know.
Thanks, Oscar.
It's hard to measure.
Thanks,
Cool.
Oscar. Can we put the slides into Astronauts?
Yeah, of course.
Okay. I don't remember the software that you were recommending for the Horizon. Maybe if you could please send me the link.
I will,
Great.
yeah.
I do have a question, though.
Sure.
Do you use the same power source for the entire rig?
Yes.
Oh, yeah, okay.
Yeah, so I just have a it's a variable it's a DC power supply with variable voltage that I think is meant for like ham radios mostly. So I think it can put out, I think the one that I have can put out something like 30 amps, which I don't get anywhere near using.
So it's not on your mains?
No, it's sitting on the floor just underneath my scope. And then it itself is plugged into a UPS, so if the power goes out, or if the power flickers, nothing goes bad. But yeah, it's just pretty standard. My mount does have some through the mount power ports, so I can plug in an input power, and then it has several outputs on the actual saddle, so I don't have to snake cables all over the place.
Okay. Any other questions? Oh, here we go.
And it looks to me like you're doing this all at f10, correct? You haven't put a focal reducer into the...
I do have a focal reducer. Yeah, I image at f7.
Oh, okay, yeah. Yeah, because finding guide stars in an off-axis guider at f10 is fun.
Yeah. I've done it. It's not bad. You might need to move it around a little bit, but yeah.
Any other questions? No?
Cool.
Well, thank you very much, Oscar. That was very detailed and enlightening. Well done.
Do you do image processing from the hot tub as well? No. Just thought I'd ask. All right. All right, we have a few observation reports. First up is Adam Bell. Thank you again, Oscar. That was great. Just ask Chris. It doesn't seem to be working. Ask him when you want to. So just tell him when you want to advance.
Okay, and the actual laser function is just the
Laser
green
is the small green one, yeah.
All right. Okay, so these are some observations I made back in September. These were the challenge objects when Pegasus was the constellation that we were looking for. So I was just going to sketch the objects, and then I thought I would try sketching the constellation too. So I sat down. This is at the Fred Lossing Observatory, and yeah, I sat down with some 2x54 constellation binoculars and just sketched out Pegasus and location of NGC 7479, which is a Superman galaxy, and M15. And you can see the tree line down here. Just looks like a bunch of lines in the dark, and that's the clubhouse. A little unconventional to sketch it. Next, please. So this was an observation with the 6-inch refractor at FLO, and I was using bino viewers. M15 looked like a nice tight cluster with some stardust sparkles in there. I couldn't really observe any arms or any extensions coming out from the globular. And then on the right, so this one, that was done with the 18-inch Star Master with the bino viewers on a subsequent night. And with that, I could see several stars, individual stars in the core, as well as what I didn't think they were quite arms, but they looked like little suburbs coming off around the globular. I just thought it was interesting to look at the same target with two different scopes, very different apertures. Yeah, it was kind of an interesting comparison. The fields are obviously different sizes, and the drift directions are different because one is an equatorial mounted scope and the other one is alt-azimuth. And I found it also helpful to identify some of the stars in the field afterwards in Sky Safari to help me orient the object and try and match up features. Next slide, please. And this was the Superman galaxy. This was a really challenging one. This was also bino viewers in the 18-inch Star Master. There was like a nice tight core that I tried to illustrate in here. And there was a nearby star with a hook around it that I could see with averted vision. And then this little slash was pretty hard to pull out, but it was there. So it kind of made, I guess, the Superman shape. Next slide, please. And this was the following night. It was a transit of Titan's shadow across the disk of Saturn. Seeing wasn't particularly good on this night. I think every once in a while, for 1 or 2 seconds, the seeing would steady, and I would be able to see the shadow of Titan against the disk. That's the advantage of bino viewers for doing this kind of thing, is they're very comfortable to observe with, and so I can sit there for I probably watched this one for, probably close to an hour, just waiting for those moments when everything would steady up and then I could see it. And then I would take a moment to fill in the sketch a little bit, and I'd look back and it would be fuzzy again, and I'd wait for my next opportunity. But this was a lot of fun. Next slide. So fast forward, now we're in February, and there was a transit of Europa across the face of Jupiter that I was able to observe. So this isn't the shadow, this is Europa itself. This was with the 18-inch Starmaster at FLO, again with bino viewers. And I watched as Europa approached the limb of Jupiter, a nice bright object. And then as it crossed onto the face of Jupiter, it happened to be on top of the south equatorial band, which is much darker. And so I was able to contrast the bright, small moon against the sort of reddish, dark band. Seeing here wasn't particularly good either, but again, when it steadied, I could pick it out pretty easily, and it was pretty exciting to see it kind of come out of the mush and just sit there in front of my eyes. But then, yeah, it would wash away again. Another interesting thing I saw with this view is that the north equatorial band seemed very wavy. There were two distinct kind of peaks and crests in the band, which I hadn't seen previously, so I thought that was kind of unusual. Next, please. And these are two sketches that I made of the moon recently. This was just in my backyard in downtown Ottawa with a 120 millimeter f5 telescope. The magnification's about 85 times. So I made the one on the right first. This is my second sketch that I tried of the moon. It went much better than the first one. This is the, I think it's, I should look up. I'm trying to remember the crater name. Gassendi. So that's Gassendi crater over here. It's got an interesting center peaks. There's a couple of them that were visible. I think there's actually 3 of them clustered in there. Kind of interesting to see that there's lava flows that crested over this low part of the crater wall and filled the crater in. And I realized as I was making this sketch that I don't really know much about observing the moon. I just saw things and sketched them, and I don't really know what they are or what they represent. So I need to pick up an atlas or maybe some good material that would describe exactly what these things are and what they mean. But it was super interesting. Of course, the best time to observe features on the moon are when they're close to the terminator. So you can see I showed that was the terminator, and the light from the sun at such a low angle relative to the features on the moon cast these shadows and really give you hints about what the structure is like. I went back to this a couple nights later when I sketched these craters, and this looked very flat and very uninteresting. So it's amazing what a couple days difference makes when you're observing shadows on the moon. So yeah, this is the other sketch here is the Mare Humorum area. So there's Oceanus Procellarum, and then there was the big Hevelius crater, which I spent most of my time trying to sketch and record the little details that I saw there. Cavallarius crater next to it, and I guess that's Lormen. down here. This was pretty challenging to sketch. There's lots of intricate details, and it's all very high contrast. And I was just doing this with a pencil in my notebook that I've got here. But a lot of fun. There's a lot to see on the moon. Is there another one, or is that it? No, that's it. Thank you, Aaron.
That's great. Thank you. Oh, Mr. Sophia. There you go. So just let Chris know when you want to advance, because that doesn't seem to be working, but the laser's working.
Oh, okay.
Okay.
Very good. Well, I took this image of Jupiter a while back at 1 o'clock in the morning on a rare clear night as clouds were approaching. I wanted to catch the red spot, and fortunately Io, one of its moons, was transiting during that time. You can see Io's shadow on the surface, and to the left of the shadow, hopefully, you see a faint beige circle, which is the moon itself. I used my Celestron 8-inch Smith-Cassegrain telescope with a 2x Barlow. And this is an AVI video file stacked with Registacks and processed with wavelets and Topaz Studio 2. Think this would work? Oh, here we go. On February 1st, I took this solar animation in monochrome and noticed a nice prominence and a pretty sizable sunspot region, as you see below. It was only later that day that I read about this sunspot region named AR4366, which was responsible for an M7.2 flare strong enough to cause a radio blackout across parts of the Earth's sunlit hemisphere. So naturally, on the following day, I set up for another look at the sunspot region, this time processing the images in color. Sure enough, it did not disappoint. I was able to capture two prominences and noticed that the sunspot region was more active than the previous day. I was using the ZWO ASI 174M camera with the software Fire Capture, and I took a video file every 30 seconds for approximately 1 hour duration. And here is a close-up of AR4366. I later read in Earth Sky News that on February 2nd and 3rd, this sunspot region was called a solar flare factory, responsible for 17 M-class solar flares and 3 X flares, with an additional 6 X flares produced in subsequent days. And when this sunspot region was no longer visible because of the sun's rotation, its flares were reportedly still visible. Flares on the sun often happen in places where there are sunspots, where the sun's magnetic fields are strongest and most complex. Flares are classified according to their strength. The smallest ones are B-class flares, followed by C, M, and X flares, which are the most potent. Sunspots appear within active regions, usually in pairs of opposite magnetic polarity, but they can also evolve into immense, very complex sunspot groups with mixed magnetic polarities throughout the group, as I believe we are seeing here. By the way, if you're interested in this subject, Jim Thompson has an excellent video called The Anatomy of a Sunspot on his Abbey Road Observatory YouTube channel, where he delves into the science and mechanics of sunspot activity. He gave a presentation on this subject some time ago. What intrigues me about this image is the huge shape of the magnetic field lines around the whole sunspot region, which shows up better at the beginning of the animation when the seeing conditions and solar surface details were best. And this is one indication of the degree of magnetic activity surrounding this area. Also note how the plasma is channeled from the sunspot at the bottom, which would be right here. And how plasma energy flows throughout the region, especially to the midpoint where you see a flare being released. Thank you.
Thank you, Jim. That's beautiful work. Jim Thompson, there you go, sir.
Thank you for the shameless promotion there, Jim. So I haven't been all that active observing in the last few months. I'm sure we're all in the same boat. One opportunity that I had to get out was on the weekend of January 23rd. Some of you may remember it. The overnight low was around -30, but it was clear, and so beggars can't be choosers. So this is a calcium 2K image captured on the Saturday, the 24th. You can see plenty of sunspot activity still, and even more brighter areas, kind of giving you the idea of the scope of the activity level on the sun at that time. And this image was a stack of the best 200 frames out of 4,000. I capture a lot of frames because seeing in my urban backyard is terrible. And also because the sun at that time of year was only at about 25 degrees above the horizon, so lots of yucky atmosphere to look through. The frames were stacked in AutoStackert. It's another free stacking software available on the internet, and I used IMPPG, yet another free software, to do all the sharpening. Next slide, please. So that image is the 56th calcium K image that I have captured of the sun in the last 7 years. I didn't know this until I decided, because the weather is so awful, I needed a project, so I decided to start compiling all of my calcium K images with the intention of trying to extract some useful science from it. So I will talk to you about that at a later date. But nonetheless, here are my 56 observations of the sun over the last 7 years. It's hard to tell at this scale, but you'll notice these images up here. There's practically no activity visible. That was at the minimum between the end of last cycle and the start of this cycle. And gradually you'll see more of the white, the bright active areas and more sunspots as we got further into the cycle. And now things are starting to peter out again because we've passed the maximum now when we're going down the other side. So we're just over halfway through this cycle. Next image, please. The other thing I have been doing, and I took the opportunity on that cold, clear weekend, is filter testing. So these are some of the sample images that I captured when evaluating some filters made by a Chinese company called SVBONY. And if you would like to read more about it, there's a link down there to the video that summarizes all the results. But the basic idea is that I've accumulated this library of filters over the years, and I can do back-to-back comparisons now very easily. If a new filter comes out, I compare that to an existing filter from my library through taking images or also through analysis that I do on the computer. And that's how I spend my time. So yes, a geek, just like many of you. I believe that's it. Oh, yeah, by the way, these images were taken, it was minus 28 degrees Celsius. And I didn't need to turn the cooler on my camera. I wonder why. All right, thank you.
Thanks, Jim. Jim, just a quick question. I was also out on that balmy night, and how does your equipment hold up to that? How do you find, do you get twitches or glitches at all?
The mount is beautiful, impeccable, at EQ8, it's a beast, so no problems there. The camera actually was not happy.
The camera is not happy? No. Oh, here. This is something that may interest others in the same boat.
So I was using a ZWO brand camera, ASI 533. It's a pretty common camera, but being overcooled and not being cooled through the heat sink from the thermoelectric cooler resulted in an uneven temperature across the sensor, and so it was very non-uniform. I had to, for what you saw there, there's a lot of gradients. That's all sensor gradients. That's not due to the sky. Oh, really? So yeah, that was a curious finding that I had. The average sensor temp was like minus 22 or something, and it was all non-uniform. So yeah, didn't like it. It worked, but it didn't like it.
You didn't like it. Okay, thank you.
I have a question about how do the SV Monty filters stack up against the more expensive competition?
They perform very well, actually. Yeah, I was very impressed. The for example, the sulfur, hydrogen, oxygen triplet, that was the monochrome pictures on the bottom. They gave the same performance as more like filters that were 4 times the price. So yeah, I'm very impressed. But you can see more about it if you go to my YouTube channel, watch the video. And there's also a test report you can get to too. Yes. Which are in the slides that Paul's going to give you. Yeah.
Thank you. Oh, another one for you, Jim.
One more for you, Jim. If it's that cold out, would it help to turn cooling on in the camera? Is this a cooled camera? In which case it might keep it within a more uniform range, even though it's not really having to do much cooling.
No, unfortunately, the way the control system, the control loop works for the cooler, it's looking for a set temperature, and if it's already below the temperature, it won't run the cooler. So it ends up drawing 0 power, and it just goes to whatever ambient temperature it wants to go to. So it needs to be, the sensor needs to be warmer than the ambient for the cooler to do anything. Anyway, so yeah, no, I tried, and it did nothing.
Thank you. The reason I asked about the equipment there, Jim, is I haven't noticed much of a problem with my mount and stuff either, but things do get stiff, and especially cabling can be a bit of a pain because some of those cables do get very stiff, and if you've got a cable, say, attached to an auto guider and it's moving, and it can tug a little bit, and you get little glitches like that. So anyway, just thought I'd ask. Now I feel better. All right, Rick Wagner. There you go, sir.
What I do is, like Oscar, I have all the cabling on the telescope, or almost all the cabling on the telescope. So as the telescope moves, the cabling isn't bent at all, because I was having a lot of troubles. Like even the connection from the mount controller to the motors, the deck motor moves enough that it would disconnect sometimes. And the other thing I do for keeping the camera running is I just run it at minus 30, and if it starts to drop below minus 30, I drop it to minus 40. So I always have darks and biases for minus 40, 30, 20, and 10. so that regardless of the temperature, I can always reach one of those temperatures, and I can always keep it below the ambient temperature. So Oscar thought he had a little bit of sky. This is my all-sky camera, what I call the NLCO sky camera, nasty little crack of sky. So this, it's also actually, it's installed in my observatory. It's an ZWO ASI 678 color camera with a 2.5 millimeter lens, the little lens that comes with the camera. And it's in a plastic pipe with an acrylic dome on it to keep it clean and protect it from snow and dew and stuff like that. But I keep it in the observatory. One of my friends in Yarker, Kevin Kell, has a similar setup, but his is outdoors. And during the day, it cooks his camera. At night, he gets frost on the dome, so he has to heat it, and then the things get hot, so he has to cool the insides to keep the camera and the computer cool, and then he forms condensation on the inside, so he has to have holes with ventilation, but then he gets bugs inside, so he has to put screens in. So I mount mine in my observatory, and it tells me what the sky conditions were overnight while I sleep. And every so often I get, well, rarely I get something like this. I had one similar to this a few years ago. In fact, the first night, within half an hour of turning the camera on for the first time, I had a giant fireball go through the field of view. This one, I don't know what this is. It has a very odd beginning or end, possibly at the top. It's kind of squared off, which is not what you would expect from a meteor. But on the other hand, maybe that's the start or the end of the exposure. This is incredibly bright.
Space junk?
Well, that's the thing. We don't know. My friend Kevin in Yarker, I mean, that's reasonably close to where I am out in Elgin. Nothing on his all-sky camera at that point in time. So if this was a meteor, it should have been high enough he would have seen it. So somebody has hypothesized that I had a helicopter go by with a searchlight on it. We are down towards Trenton, so we do occasionally get military helicopters go by. But why they would be flying along at, 6 minutes past midnight and shining a spotlight down on our house, I mean, I keep all my weapons under cover, so there's... Anyway, so, I don't know, looks cool anyway. You can see a bit of scatter and stuff from the acrylic dome. Anyway, next, Chris, please. So this is a video, a little bit of a video from the all-sky camera. Can we start it, Chris? So you can see that the telescope was starting out, and now it's gone off and observed. And all of a sudden, little bits of aurora go by, then pow! And then this white glow, and then it was pretty much over. And the whole thing took like 4 or 5 minutes. So, and unfortunately, like Oscar, I go out, I open everything up, I start it, and I go back in the house. And 10 minutes later, that goes by and I completely miss it. Can we run it again? So this is just overexposed because of twilight. I think the white glow at the bottom is probably light pollution from Kingston. Lots of airplanes and satellites go by, of course. And then there's this weird white glow off to the west, the right, that I don't know what that was either. I mean, you don't normally think of white aurora, but anyway. So that's one of the benefits to being outside at night. Any questions? All right, thank you.
Good. Thanks, Rick. Okay, John Thompson, are you doing us remote or? Oh, there you are. Cool. Can't hear you. Have you got your
There, can you hear me now?
Here we go. Yep.
Okay, I had actually intended to be there. I just got back from Churchill, Manitoba about 24 hours ago, and it wasn't until a little over an hour ago that I realized that I was still living on Eastern Standard Time. So even if I'd made it in, I would have been an hour late. But, and the final decision was there was a heavy snow coming in this rural area where I live on. The roads hadn't been plowed, so you couldn't even see the road markings, and it was looking rather treacherous. So I made a last-minute decision not to make it there. But I did accompany Martha Farkas, who's been with our group for a while, up to Churchill. We went from the 5th to the 11th, so it was 6 days and 5 nights. And of the 5 nights, 4 of them were clear. So we had 4 nights, and all 4 of those nights, the auroras appeared. Now, you probably know that Churchill is right under the auroral nova, or auroral oval. Its coordinates are about 94 west and 58 and some maybe close to 59 north, which puts it right under the auroral oval. And so the science director was giving us lectures on astronomy and the process of the aurora, mentioned that at that latitude, the Kp value, which is a key indicator of the Earth's magnetic field's activity or variation disturbance, really is it really has no meaning when you're right under the auroral oval, because we get aurora practically all the time. But just like here, they're ephemeral. They come and go. You have to be out watching. And he took it upon himself with an all-sky camera to watch when they were there or not there. And if it was the middle of the night, he would walk down the corridor and saying, "Showtime," and knock on everybody's door. So everybody would get out of bed, run outside, and try to see what they could see. And the aurora might be there for half an hour, and then it would disappear again. So it was a bit unusual. This picture is sort of like me with a selfie that I took with my 360-degree theta camera. And right now it's showing as what they call I forget what it's called, but it's essentially a Mercator map projection, but it can be turned into a photosphere, which you can look at in all directions. Next slide, please. This is another night. This was, I believe, the last clear night that we had, and the Kp value was only 1.6, which is practically 0, and yet we still get good auroras, even at that low value. One unusual thing that differs from our latitude is that the auroras are virtually stationary. There's no flickerings, no pulsations, no arcs or rays forming. Occasionally there would be a ray, but generally you would have to watch for 10 to 20 seconds to see any motion at all. There was no, or practically no real motion or like translation. And Ron, a science director, when I asked him about that, he said that in his experience, it's always like that. For some reason, you just don't get the activity that we get at lower latitudes. Oh, off in the distance there, to the right is the building where we're staying in, called the Churchill Northern Studies Center. And it has 21 rooms which can accommodate up to 84 researchers. They have 2 double bunk beds in each room, but fortunately we were able to get our own rooms. It wasn't too crowded. And off in the distance, looking straight forward, there's a utility building that has some of their equipment, but there's also, it's almost like a hydroponic farm, which they call rocket greens. And that's a play on the rocket, sounding rockets that they used to shoot up there. But it's all hydroponics, so they provide all of their greens and veggies and everything for the kitchen, and they did feed us very well when we were there. Next one, please. Oh, on my return trip, I stopped off at the Manitoba Museum, and they have a planetarium there. Unlike Ontario, I don't believe there's any planetarium at all. You have to go to Montreal for the Dow Planetarium if you won't see anything. But I sat through their 30-minute show with about 100 6 to 8 years old because they were having 3 school field trips that day. And interestingly, they don't use that old Zeiss projector anymore. It's just there for show. They have a modern, like computer-controlled projection system, but for some reason they decided to use or keep the old Zeiss in place there. The next one. Oh, it's just another shot, but you can see some of the, I think it's mythological figures and things. It was a 30-minute show. The first 15 minutes was basic sky motions. They assume that the only things that most people know are Orion's belt and the Big Dipper, and then they showed how the Big Dipper can be used to find north, and basic sky motions, seasonal sky motions, showing that the Dipper is up high during the summer and it's low in the wintertime, and then it's horizontal during the spring and fall. Next one. Oh, well, I forgot to mention, 15 minutes of the sky talk, and then the remaining 15 minutes was a recorded audio track, which they sort of accompanied with images of a Cree elder describing sort of the Cree take on the skies and what wisdom and learnings can be found from the traditional teachings as part of the Truth and Reconciliation program. And he did say that obviously the Crees is not definitive or the only one, but all cultures have their own sort of mythology and understandings of how the sky can teach us things. This is again in the museum showing one of the sounding rockets, the Black Grant they call it, which I always wondered, the Black Grant is actually the name of a goose, I think it is. But they named their sounding rocket after that. And NASA, or the American military perhaps, actually used sounding rockets up in Churchill also I think it started in 1957 with the International Geophysical Year. And they were doing studies also as part of the Cold War paranoia. Apparently there was some rumor that the Russians were doing things to affect the upper atmosphere and the ionosphere in order to disrupt long distance communications. So perhaps that was one of the reasons that they're sending sounding rockets up also. And then that big screen is a video showing the aurora is actually flickering and bit of motion, which we actually didn't see with the naked eye. Okay, next one. I think this is the last one. Is there something there? I can't see an image. Is it okay? It looks like the image. Oh, okay. Looks like the image wasn't bright enough. What it was what the science director he called what he had a money shot. That was supposed to be my money shot. It showed Orion surrounded by the winter hexagon, which is, from memory, it's Rigel, Sirius, Procyon, Pollux, Capella, and Aldebaran. Although right now, Pollux is substituted by Jupiter, which is even brighter. And so it makes the big hexagon in what they call the winter hexagon, with Betelgeuse more or less in the center. But accompanying that is a nice bright aurora, which is looking westwards again towards the rocket greens facility, the hydroponic facility, and some of their other buildings. So anyways, that was an amazing trip. I kind of smiled when people were talking about temperatures. We had 2 or 3 days which Environment Canada was giving yellow severe cold warnings. The high ambient temperature was around minus 30 something, minus 32, minus 33. and with wind chill, it was up to or down to about minus 55. We were doing a lot of outdoor activities. We had to keep fully bundled up with ski goggles and balaclavas and full face measures. Otherwise, we'd be risking frostbite. And the device batteries really don't work much at those temperatures and not very well. I had a tablet, a cell phone, and my 360 camera. And generally, their batteries, you'd be lucky to get 10 minutes out of them before they shut down at those temperatures. My Canon full frame DSLR seemed to fare a little better because it had bigger, thicker, higher capacity batteries. And I was able to get a number of images, including some video, using that, and it didn't shut down, but I did have a spare battery to swap in. So anyways, anybody gets a chance, I would really encourage you to go up there. And there's all sorts of interesting activities in addition to the auroras. I mean, they have a number of in-house and contract researchers that gave some fascinating talks. We were doing things like snowshoeing, building igloos, dog sledding, and walking across the tundra, looking for ptarmigans and other native birds, Arctic hares, Arctic foxes. We saw traces of them, not the actual animals. And I'm just putting in a plug for this because they are a nonprofit organization and they depend on ecotourists and science tourists like me and Martha to go up there to help support their activities. So anyways, I'll provide a link somewhere. And again, it was an amazing experience, and I would encourage anybody else to try to do it if you have a chance. Thanks a lot.
Thank you, John. Certainly sounds like an interesting trip. All right.
It was.
There we go. All right, I just have a couple of things to show you there. Just a little follow-up on our interstellar visitor, Comet 3I Atlas. I showed you this last month because at that time this was the last photo I had obtained of it back on December the 28th, when it was already on its way out, 1.8 astronomical units away from the Earth, and down to magnitude 12. In the intervening time, as you've heard many of us whining about, there haven't been a lot of clear nights there, but I did get one more shot at that comet about 3 weeks ago. So if I could have the next slide, please. There we go. So this was on February the 15th. Its magnitude had dropped to, well, there's varying reports from 16.1 down to about 17. Getting pretty dim. Getting pretty dim there. You can see it at the center, and maybe we can advance the next one. I'll give you a close-up of it so you can see the little beastie. So there it is there. The tail obviously much diminished, and the brightness in the coma also very much diminished. At this point in time, it was already 500 million kilometers away from us here on Earth and approaching the orbit of Jupiter. So it's it's moving out at a serious speed. I think currently it's pushing around 56, 57 kilometers a second. So I hope it enjoyed its year-long or almost year-long visit into our system, and now it's back off into interstellar space for, who knows, maybe another billion years or so. By some analyses of its possible origin, I may have mentioned this in the past, but by some of those analyses, it appears to have come from more in towards the center of our galaxy, and it may have been orbiting around, just as our sun goes around the center of our galaxy, it may have been doing that for several billion years, perhaps even longer than the Earth has been around. So God knows how many other systems it's happened to trip around. And it was interesting to be able to see it because, as I've mentioned before, this is only the third such known interstellar object entering our system. So we may see more of those in the future, especially with Vera Rubins and other systematic telescopes getting ready to do a lot of sequential imaging of wide swaths of the sky. So we actually expect to see more of these, but really this is only the third one that we've noticed so far. Okay, next one, please. This is one I took. I wasn't really actually planning to show this one because it was just a test shot. I was testing a configuration of a certain camera with a small telescope, and it's the Virgo cluster. And last month, John Thompson mentioned that there was a supernova, and he showed us an image of it. It was just recently discovered. And when he mentioned where it was, I thought, well, I was trying to run these calibration shots up in that neck of the woods too. Click once there, Chris, if you would. I've got some labels there. This is a wonderful region. I mean, the Virgo galaxy cluster is just chock full of galaxies there, and this is a fairly rich region of that cluster, and I've labeled some of the major players there. But the object of interest was a supernova that detonated in one of the galaxies, specifically NGC 4168 up at the top right. And if you can go to the next one, Chris, a bit of a close-up on that. And click once again, if you would. There we go. There's the supernova, and it's determined that it was a component or a star in NGC 4168. So, needless to say, if you were in the vicinity of that star 100 million years ago when it detonated, it was probably a pretty bad hair day. It certainly would have taken out any of the planets that orbited around it. But yeah, it was kind of fluky that I managed to get this unplanned shot of the thing that John mentioned there. So I hope you're seeing that, John, too. Thanks for the inspiration on that. Okay, I think that's it for me. And run with the next one there. Okay, Richard, lucky man, is touring New Zealand and I think Australia as well for the next month or so, month or two. So he's obviously not here tonight to do the observing challenges, and he won't be next month as well. So I'm just sort of filling in quickly for him here. Those were the challenges last month. I won't go over them because we're already running a bit late on time. If you were out last month, if you got a clear sky, you already know what those challenges were. Next one, please, Chris.
Your clicker should work.
Oh, should it work now? Give it a try. Oh, it does. Look at that. Okay, and Mark actually captured apparently a nice image of one of the objects there from last month, M106 Galaxy. But there was a conjunction there with Mercury, I think it was, that was clouded out. Sorry if I'm a little weak on the details here. He did leave me some notes. This is the constellation challenge for the coming month. This is a constellation called Mitsubishi. It's kind of like Mitsubishi, but not quite. But this is a native interpretation of that pattern in the sky, which more commonly to us is known as the constellation of Leo. You can see him behind, and Cancer, the crab. They saw it as a very different animal, a lynx, in fact. And you can see also that they had. Oh, I can use my pointer. You can see also that they also use the same pattern of stars that we use in terms of Ursa Major, the Big Bear, which contains the Big Dipper. All right, so that's his constellation challenge. Try to see if you can see that constellation. Where's my laser? There again. Again, more recognizable and certainly probably more visible in your star charts. It's basically using the same stars, the Hook and Leo there, and the brighter stars in Cancer to form the Lynx. All right. And the next one here. So I've added this to his collection to show you where the challenges objects are. They're a little easier to reconcile with the charts that you probably have on hand or on your device. So whoops, sorry. Go back. Back. So the challenge objects here are the head of the Hydra. Hydra is a very long constellation, but low to the ground, basically. It snakes along for a good long distance there, but the head of the Hydra is actually fairly easy to see. So if you can find Leo and Regulus right there, and look over to Procyon. So Procyon is in the little dog near Orion. The head of Hydra is a very noticeable circular pattern of stars that you can see that's halfway between Regulus and Procyon. The other challenges that he's put out is the Leo Quartet, which is up here. These should be relatively easy to find. The difficulty in them is that they are fairly small objects, and some of them are fairly dim. They're galaxies there, but the hook of Leo there makes it easy to find. The Leo Quartet is a collection of 4 NGC galaxies clustered very, very close together and almost exactly halfway between the 2 bright stars in the hook of Leo. And then ARP 94 is just off to the east of I think it's Algeba. See, he's got the listing here. There we go. So yeah, constellation, the head of the Hydra. The Leo Quartet is the 3rd level challenge, and ARP 94 is the more challenging of the objects because they are fainter. His solar system challenges, he recommended searching for small features, the smallest features that you can see or observe or image on the moon. I'll quote what he's got here. In the light of the upcoming Artemis 2 mission to the moon, with Canadian astronaut Jeremy Hansen on board, Richard says, let's show him how we can see and photograph small features on the moon using our own telescopes. So the challenge is, what is the smallest object you can see or image on the moon? Fairly easy. So if you get a chance to check out the moon, imaging or sketching, and you think it's a really small feature, feel free to share that observation with us next month. All right. And I believe that's it. So Fred Lossing Observatory, we've got some star parties. Oh, look at that. That happens to be in 2 days. But yeah, I don't. Yes?
We're already calling a no-go for tomorrow night, but the backup, I think, no, it's supposed to be March 21st, next weekend.
Oh, next weekend? Is the backup date? Yeah. Okay, yeah, because tomorrow night looks like a wash.
Yeah, no go for tomorrow, hopefully on the 21st.
And that should have read March 14th, I take it, because that's, it's the 13th today. Yeah, anyway, so yeah, no go for tomorrow night. So rescheduled for March 21st. Thank you. Okay, and this is for members only out at the FLO Observatory. All right. Then we have a notice of Earth Hour. Is there somebody presenting on that, Chris? Do you know offhand? Or is it just basically a reminder of Earth Hour, and that occurs on March the 28th this year at 8:30 p.m. Turn off your lights, see how dark the sky really gets. If we all do that, there's been times where they've done this, where it gets noticeably nicer to observe, especially if you live in suburbs or especially in the middle of a city. All right, club information. There we go. Stan Mott Book Library. That position is no longer open. I'm happy to announce that Rachel Chan and John Thompson have taken over that from Estelle. So thank you very much. They are in the process of looking at what we have, and they're going to share thoughts. They both have library-related experience. They're going to share some thoughts and see what we can do. We're hoping to get a digital catalog, a full digital catalog of what we have available, which will make it easier for members to have a look at online and then request a book rather than having to spend time looking through all the stuff that we have. So stay tuned for that. Developments are happening. All right. Thank you again, everybody, for everybody that contributed observations and the presentations. We did have 40 tonight here at CASM, which surprised me, given the less than ideal weather conditions, and we had 43 on Zoom, so 83 in total. And again, we thank the RASC National Office for the use of their Zoom. Any comments that you have? Send them to me at meetingchair@ottawa.rasc.ca. And I think that's about all we have. So our next meeting is scheduled, and I believe is still scheduled, for February the 10th, or April the 10th. We've had to bump our dates in the last couple of months because of the imminent potential launch of the Artemis 2 mission. That has now been rescheduled. It is supposed to go off early in April, so I don't think we'll have to reschedule this, but who knows, right? But the next window apparently opens in the first week of April, so we should be okay for April the 10th at 7:30, which is the second Friday in April, thanks to Easter. All right. And again, any observations and ideas, send them to myself and Chris. And a reminder that the rest of the museum, as you leave, is closed to us. Thank you very much for coming. Have a safe drive home, because it may be a little dicey out there. Thank you.